Hello everyone, welcome to our channel GYANKALYAN. In the previous video, I have discussed about the properties of acids. In this video, we will continue with an important topic of this chapter, that is bases. Now what are bases? Bases are those chemical substances which have a bitter taste. Unlike acids, which have a sour taste, bases are the chemical substances which have a bitter taste. The solutions of substances like caustic soda, lime and washing soda are bases as they are bitter in taste and slippery to touch. Caustic soda, washing soda or lime, these are the examples of bases. These substances are bitter in taste. When you taste them, you will find it to be bitter and they are slippery to touch. When we touch bases, we will find it to be slippery. So bases can be defined as those chemical substances which have a bitter taste and they are slippery to touch. So all the bases change the color of red litmus to blue. Bases are the chemical opposites of acids. Okay, when bases are added to acids, they neutralize or cancel the effect of acids. So we can define base as a chemical substance which can neutralize an acid. It is considered to be a chemical substance which can neutralize the acid. All the metal oxides and metal hydroxides are bases. For example, sodium oxide, which is a metal oxide, and sodium hydroxide, which is again a metal hydroxide. Both of them are bases. Again, we can say about calcium oxide or calcium hydroxide, both of them are bases. We have earlier studied in the properties of acids that when a metal oxide is added to an acid, salt and water are formed, which is a neutralization reaction considered equally as bases. So these metal oxides are considered to be bases. Again, we have metal carbonates and metal hydrogen carbonates, which are again bases as they can also neutralize the effect of acids when added to them. So we again have bases such as sodium carbonate, calcium carbonate or sodium hydrogen carbonate. A base which is soluble in water is called an alkali. Most of the bases do not dissolve in water, but some of them dissolve in water. So those bases which dissolve in water without going any further chemical reaction are given a special name, and that name is alkali. Some of the common water soluble bases or alkalis are sodium hydroxide, potassium hydroxide, calcium hydroxide and so on. So these soluble bases or alkalis are much more useful than the insoluble bases because most of the chemical reactions take place only in aqueous solutions or water solutions. So these soluble bases are much more useful than the insoluble ones. Now, what do all the bases have in common? So what do all bases have in common? Okay, when a base is dissolved in water, it always produces hydroxide ions in solution. So what all the bases have in common is that whenever the base is dissolved in water, it will produce hydroxide ions in water, that is OH negative. Thus, a base is a substance which dissolves in water to produce hydroxide ions in solution. For example, sodium hydroxide is the base because it dissolves in water to produce hydroxide ions along with sodium ions. So, whenever a base is dissolved in water, it will produce hydroxide ions and the metal ions will be produced which is present in the base. For example, here sodium hydroxide, the hydroxide ions are produced along with sodium ions. So, the basic character of a base is due to the presence of the hydroxide ions in it. A sodium hydroxide solution shows basic behavior due to the presence of hydroxide ions in it. Similarly, other bases such as potassium hydroxide, if dissolved in water, will give hydroxide ions along with potassium ions. Or you can say magnesium hydroxide, which is a base, if it is dissolved in water, it will produce hydroxide ions along with magnesium ions. So, a common property of all the bases is that they all produce hydroxide ions when dissolved in water. So, when a base is dissolved in water, two types of ions are produced. One is the positive ion, which is also known as cation, and the negative ion, which is known as anion. So, in case of sodium hydroxide, the positive ion, that is the cation, is the sodium ions. Sodium ions are the cations and hydroxide ions are the negative ones, that is the anions. So, whenever you dissolve a base in water, it will produce ions, and as hydroxide ions are the common ones in case of all the bases, so base, what do they have in common? They have the hydroxide ions. They will produce hydroxide ions when dissolved in water. Again, we have two types of bases, strong base and weak base. So, what is strong base? A base which completely ionizes in water and thus produces a large amount of hydroxide ions is called a strong base or a strong alkali. So, a base, when it is dissolved in water, completely gets ionized in water and will produce a large amount of hydroxide ions. Then that base is a strong base. Examples are sodium hydroxide, potassium hydroxide. These are strong bases because they get completely ionized on dissolving in water to produce a large amount of hydroxide ions. Again, in the case of weak bases, a weak base is a base which is partially ionized in water, which is not completely ionized in water, and it produces a small amount of hydroxide ions. So, the base which produce a small amount of hydroxide ions on dissolving in water is called a weak base. Examples are ammonium hydroxide, calcium hydroxide, because they ionize partially on dissolving in water and produces a small amount of hydroxide ions. What happens is that when a strong base is dissolved in water, then most of the molecules of the base will dissociate in the water to produce large amount of hydroxide ions. So, these bases are known as strong bases because most of their molecules will dissociate and they will produce large amount of hydroxide ions. But in the case of weak bases, the base will get dissolved in the water, it will dissociate, but not many of the molecules won't dissociate. Some of them will dissociate and give the hydroxide ions, will produce lesser amount of hydroxide ions. So, they are known as weak bases. In the case of strong acids and weak acids, when you dissolve acid in the water, most of the molecules of the acids will get dissociated and they will produce a large amount of hydrogen ions. So, they will be the strong acids. But in the case of weak bases, the bases will dissolve but not most of the molecules will get dissociated, lesser amount of the molecules will get dissociated and they will produce a lesser amount of hydrogen ions. So, these acids are known as weak acids. Now, let us discuss about the properties of bases. So, the first property, bases have bitter taste. The chemical substances which are bitter in taste are generally the bases. Bases feel slippery or soapy to touch. So, whenever you touch a base, you will find it to be slippery. For example, if we rub a drop of sodium hydroxide solution between the tips of our fingers, we will begin to feel soapy or slippery as if we have applied soap on our fingers. So, this is because the bases are slippery to touch. The next is bases turn red litmus to blue. When you dip a red litmus paper into a basic solution, you will find the color changes from red to blue. For example, sodium hydroxide solution, if you dip a red litmus paper in it, you will find the color changes from red to blue. The next property is bases conduct electricity in solution. That is, they are electrolytes. So when a base is dissolved in water, we know it splits up into ions, hydroxide ions and the metal ion present. So due to the presence of these ions, the solutions of the bases conduct electricity. Bases react with some metals to form hydrogen gas. When a base reacts with a metal, then a metal salt and hydrogen gas are formed. For example, when sodium hydroxide solution is heated with zinc, then sodium zincate and hydrogen gas are formed. In this reaction, we can see that sodium hydroxide solution is the base. It is heated with zinc, which is a metal. Therefore, we see the formation of sodium zincate, which is the metal salt, and hydrogen gas. Okay? In the salt formed by the reaction between the base and the metal is present as a part of the negative ion or the anion. So in this particular example, the sodium zincate salt, the metal zinc is present as the part of the negative ion, that is zincate ion. Again, it is very important to note that all the metals do not react with bases to form salts. You can see that it is written bases react with some metals to form hydrogen gas. So all the metals do not react with bases to form salts. The next property, bases react with acids to form salt and water. So this is the neutralization reaction, similar to the one we found in the properties of acids, where acids react with bases to form salt and water. So when a base reacts with an acid, then a salt and water are formed. For example, when sodium hydroxide reacts with sulfuric acid, then sodium sulfate and water are formed. So sodium hydroxide, which is a base, reacts with an acid, sulfuric acid. Then sodium sulfate, which is a salt, and water are formed. So this is a neutralization reaction. We know that all the acids produce hydrogen ions when dissolved in solution, and all the bases produce hydroxide ions when dissolved in solution. So when an acid and a base react with each other, or when they are combined, the neutralization reaction takes place as the combination of the hydrogen ions present in acid and the hydroxide ions present in the base combined to form water. The reaction can be shown as this one. Hydrogen ions reacts with hydroxide ions to form water. So we have the last property. Bases react with non-metal oxides to form salt and water. For example, calcium hydroxide reacts with carbon dioxide to produce calcium carbonate and water. So calcium hydroxide is the base. It reacts with carbon dioxide, which is a non-metal oxide. Carbon dioxide is a non-metal oxide, and it will produce calcium carbonate, a salt, and water. So the reaction between the non-metal oxides and base is similar to the neutralization reaction, which shows us that the non-metal oxides are acidic in nature. Now see what happens to an acid or a base in a water solution, or what will happen when an acid or a base is added to a water solution. Water is slightly ionized into hydrogen ions and hydroxide ions. In pure water, the concentrations of both the ions, that is the hydrogen ions and the hydroxide ions, are equal. So pure water is neutral. It is neither acidic nor basic. But when an acid is added to water, it will produce hydrogen ions. The concentration of hydrogen ions in water increases. The solution of acid which is formed will have more of hydrogen ions and less of hydroxide ions. The hydroxide ions will come from the ionization of water, So, due to the presence of excess amount of hydrogen ions, the solution will be acidic in nature. Hydroxide ions are also present, but their quantity is less in comparison with the hydrogen ions. When bases are added to water, then the concentration of hydroxide ions increases in the solution. So, bases produce hydroxide ions in water. The solution formed by dissolving base in water will have more of hydroxide ions in them. The concentration of hydroxide ions will be more. Hydrogen ions are also present, but they are less in concentration. So, the solution will be basic in nature. Why? Due to the increase of hydroxide ions in them. So, we have come to know that both acidic and basic solutions contain hydrogen ions, and both acidic and basic solution contains hydroxide ions, but their concentration in both acidic and basic solutions are different. In acidic solutions, the concentration of hydrogen ions are more than that of hydroxide ions, giving it the acidic character, whereas the concentration of hydroxide ions in bases is more than that of hydrogen ions, giving it the basic character. The process of dissolving an acid or a base in water is a highly exothermic one. The acid must always be added slowly to water with constant stirring. So the reaction which takes place while we add an acid or a base in water, it is an exothermic reaction. A lot of heat is evolved in this reaction. So the acid must be added slowly and the mixture has to be constantly stirred. Okay, proper care must be taken while we add concentrated acids like sulfuric acid or hydrochloric acid with water while doing our practicals. The acid must always be added to water with constant stirring. Remember one thing, acid is added to water, water is never added to acid. The process of dissolving an acid or a base in water is a highly exothermic one. The acid must always be added slowly to water with constant stirring. So the reaction which takes place while we add an acid or a base in water, it is an exothermic reaction. A lot of heat is evolved in this reaction. So the acid must be added slowly and the mixture has to be constantly stirred. Okay, proper care must be taken while we add concentrated acids like sulfuric acid or hydrochloric acid with water while doing our practicals. The acid must always be added to water with constant stirring. Remember one thing, acid is added to water, water is never added to acid. If water is added to a concentrated acid, the heat which is generated may cause the mixture to splash out and cause burns. Because when water is added to the acid, a large amount of heat will be produced which is harmful, which is dangerous. So it may cause the mixture to just splash out of the container, or the container itself may also break due to excessive heating. So that's why it is recommended or it is advised to not add water to the acid. We should always add acid to water with proper care, slowly and with constant stirring. Mixing an acid or a base with water results in decrease in the concentration of hydrogen or hydroxide ions per unit volume. Such a process is called dilution and the acid or the base is said to be diluted. So, what is dilution? The process when we mix an acid or a base with water, there is a gradual decrease in the concentration of the hydrogen ions or the hydroxide ions present both in the acid and the base will decrease per unit volume. So that process is called dilution. when we add an acid or a base, due to which the concentration of hydroxide ions or hydrogen ions will decrease per unit volume. Such process is called dilution, and the acid or the base is said to be diluted. We will call that acid or base to be a diluted one, like dilute hydrochloric acid or dilute sulfuric acid, when water is or the acid is added to water. The concentration decreases. Now comes how strong are acid or base solutions, or the strength of acid and base solutions. So we have studied about the presence of hydrogen and hydroxide ions in both acidic and basic solutions. The concentration of hydrogen ions in acidic solutions and the concentration of hydroxide ions in basic solutions, and we came to know that both the ions are present in acidic and basic solutions, just their concentration or quantity differs from each other. Acidic solutions have large amount of or more amount of hydrogen ions in them, whereas basic solutions have large amount of hydroxide ions in them. Now, in 1909, Sorensen devised a scale known as pH scale, on which the strength of acid solutions as well as basic solutions could be represented by making use of the hydrogen ion concentration in them. So Sorensen, a scientist, devised a scale which is known as the pH scale. It is used to check the strength of acid solutions as well as basic solutions by making the use of hydrogen ion concentration in them. Hydrogen ion concentration is made as a basis to check the strength of the acidic or basic solutions. He linked the hydrogen ion concentration of acid and base solutions to the simple numbers 0 to 14. Okay. Now, the pH of a solution is inversely proportional to the concentration of hydrogen ions in it. That means, if the solution having a high concentration of hydrogen ion in it, if a solution has high concentration of hydrogen ions in it, then it will have a low pH. Okay. If the solution has less concentration of hydrogen ions, then it will have a high pH. So, on the basis of the concentration of hydrogen ions in the solutions, we can check the pH scale and the strength of the acidic solutions and the basic solutions. The P in pH stands for potens in German, meaning power. Okay. On the pH scale, we can measure pH generally from 0, that is very acidic, to 14, very alkaline. As we know, the concentration of hydrogen ions in acids are more, so the pH is low. That's why 0 is said to be very acidic. From 0 it will start, and till 14 it will become very alkaline. That is, the concentration of hydrogen ions will gradually decrease and it will be the basic solutions, so the pH will be 14. The pH scale is used to measure the strength of an acid or base. It is a scale of numbers from 0 to 14. The P stands for potens and H stands for hydrogen ion concentration. pH is a pure number, it has no units. So, now we will see the different pH of substances. Okay. Neutral substances have a pH of 7. The pH of a neutral solution or substance is 7. That means it's neither acidic nor basic. Pure water is a neutral substance. A sugar solution and sodium chloride are neutral, each having a pH of 7. And it also means that a substance having pH 7 will have no effect on litmus or any other common indicators, such as methyl orange or phenolphthalein, there will be no effect on their indicators.